Welcome to ETHDam, to ETHDam, to ETHDam, to ETHDam, to ETHDam.
Mattevz from Oasis. He's talking about ROFL. He's giving the 201 workshop. As he just said, he gave the 101 workshop a few days ago. Thank you very much.
Hello, hello, dear hackers. Okay, so on Tuesday, I held a 1-hour workshop on ROFL 101. So we discussed like what's all about ROFL. Basically, ROFL is a off-chain version of the confidential computer we have on our blockchain. It's called Sapphire blockchain, the EVM compatible, confidential. I think it was the first one in production. And then we discussed this ROFL thing, which is basically the off-chain version of what you can do on-chain. You can do off-chain. It's still running inside the TEE, so you can trust the computation, but you can do more, compute-intensive apps like AI, gaming, and so on. And we discussed how ROFL app looks like, the components. You have this configuration file called the manifest file, ROFL.yaml. And then you need to register your ROFL app on-chain. You need to pay some fees for that, but basically you just stake your assets there, and then once you deregister the app, you get those assets back. So this is basically just for the spam protection. All right, and then you build your ROFL. There is a ROFL bundle called the .org file, and then you deploy that org file to our decentralized cloud. So basically, anyone can be a cloud provider, and as long as it has this TDX, the Intel's TE version of hardware available. Right. So today, I'd like to point out more powerful features, and let's get back to it. For starters, I will just take the Telegram bot we developed in the ROFL 101 workshop. Okay, and the first feature I'd like to point out is that. Back in the previous workshop, we just had one Python script packed inside the Docker container. But you can have multiple Docker containers orchestrated, running in parallel inside the same ROFL app. So why do you want to have that? For example, you have a chatbot, but basically you want to connect that chatbot to some LLM model, for example, LLaMA. And ideally, it would run inside the same bundle, and the conversation never leaves the TE. So that was the original motivation. So how do we do it? This is standard compose syntax, so nothing new here, Oasis specific. Basically, inside your compose YAML file, you just add another service. In this case, I call it LLaMA, and you define where this image lives and so on, and you expose ports. So this ports section is mandatory, and it basically means that the port 11434 in this case will be exposed externally, and you can have other containers connect to this LLaMA container and speak to it. Okay, and in the Python, this is Python, yeah. In Python, in this example, so this is snippet, you have access to these PDFs. I posted it on Telegram and Discord channels, so you can copy and paste it. But basically, I use this LLaMA Python package, and you simply provide the URL. So the URL should be LLaMA and the port, so just a standard syntax. And basically, you can connect this way to the other container. And the command here is that basically, in the last workshop, we had /hello, which just pongs you back the hello Matevz. And now I have another command called clear to remove the history. And whatever else comes in, it's a conversation for your bot. So basically, if you type what's the population of Amsterdam, I don't know, that will be redirected to LLaMA and returned back to you. So yeah, this is the history here. So it's per user history. So it's a very 50 lines of code chatbot speaking to LLaMA. How cool is this? Okay, the second feature is persistent storage. So it's a decentralized system of ROFL providers that run your ROFL app. And one of the questions was how do you do storage? So you have some data, and you want that data to be shared among multiple instances of your application. And the only proper way to do it is using blockchain. So blockchain is a root of trust. Whatever is on blockchain inside the smart contracts, for example, that data is always available to any node out there. So this clearly works. But if you take the LLaMA example, so the first thing LLaMA does is you need to download the model. I know, the DeepSeek model, 1.5 gigs of tokens. It needs quite some space and quite some bandwidth to spin up. So we need some persistent storage on host that each time you, for example, restart your machine or restart your Raffle app, it doesn't download again. So you need to have some kind of persistent storage, of course, per node, per machine. It's not distributed, it's just local. But the problem now here is that we are doing TEE, right? And when it comes to storage, you basically need to encrypt everything. So we set up this LUX device, and from the host point of view, it's just a random blob on his hard drive. And inside this, the TEE is using the storage and decrypts it and actually to read the content. So it's a TEE still, and the storage, the persistent storage is like safe to use. So how do you configure to use the persistent storage? Well, this /storage folder is basically exposed to your containers, so you can just simply bind mount it. So this is again the compose file. If you want, for example, to have this root.llama folder to be persistent, you do something like mount storage llama to my root.llama folder inside my container. So this way, the first time the Raffle app is spun up, it will download the LLM models. The second time, for example, if it's upgraded or restarted, the persistent storage will be there, and it will just start immediately because the model will already be there. When you upgrade your Raffle, the persistent storage remains intact. Okay, and the third, a very strong feature, is slightly more complex. It's about integrating your Raffle app with Sapphire. So Sapphire, as I mentioned, is our confidential EVM. And it basically, so it allows you to have smart contracts, and the smart contract state is on-chain, it's encrypted. So basically, if you want to dump a smart contract state, you will just get random blobs, or actually we even just return 0 for the sake of, yeah. Right, so how do we do it? We set up a service called AppD. So it's an application daemon. It's a simple REST service, and you can use it by binding to this Unix socket. So on a host, it's called /run/raffle-appd.sock. And usually just you want to map it inside the same file, at least in our examples, that's how we do it. And then you connect to that socket, and the HTTP request header should begin with HTTP//localhost, and then the endpoint you want to use. Okay, now what are the endpoints? The first endpoint is the app ID. It just means that give me the app ID I'm currently running, and that's it. So the app ID is the one starting with Raffle 1 something, so it's a batch 32 encoding. And this is, for example, if the app wants to know of its identity, it's useful. Yeah. Okay. The second endpoint is if you want to generate a key pair. It can be either the ED25519 or the standard SEC P256 key pair. And it's generated inside the TE, but it's not generated each time. It's just derived from the key, some key ID you provide. So this is, for example, if you have some app-specific key pair you need, and if you will provide the same ID of that key, like the my LLaMA key, for example, it will always derive the very same key. So request here in our example is a demo key. We define the kind, so it's a standard JSON, and the response is the hex encoded 32-byte long private key you can then use in MetaMask or whatever. Now, why is this useful? Let's see. The third endpoint is called sign and submit. And this endpoint, you provide the standard Ethereum transaction, and it signs the transaction with the unique Raffle key and submits it on-chain. Okay, and this is useful because when you're running a smart contract, you need to know whether the transaction originated from Raffle app. Okay, this is may not sound so complicated, but it is because if there's a transaction and you see the transaction was signed, okay, with some public key, okay, with some key pair, okay. How can you make sure that this key pair never left the TEE? Okay, because the first thing is, if you say some account is allowed to post transactions, then you need to generate the key pair for that account. And if you generated it somewhere outside of the TEE, that's the game over, right? You cannot assure that the key hasn't been compromised yet. So you must generate it inside the TEE. And then once you generate it inside the TEE, you need to make sure that that key was never exposed during the lifetime of the Raffle, because you can have upgrades, you can have number of containers accessing that Raffle. So you need to have a very strict policy to audit like all history of all the images, all the Raffle upgrades that ever was running inside that Raffle. So that's the second thing. So we have this Raffle upgrades, and each upgrade is all the images are signed. So you can then verify the whole history and audit specific, snapshots of those images. Okay, and then once you have that, you still have just a single key. And then inside a smart contract, how can you verify like which key is then the right one that originated inside Raffle? And for this reason, we added a special call. It's called the Raffle ensure authorized origin. And it works like this. So for example, let's have a simple smart contract that stores quotes. For example, the Rose USD prices on Binance. And this contract would look like so. So in this submit observation is something that's running inside the Raffle fetches quotes and then wants to send it on-chain, store it on-chain. And this submit observation needs to have this authorization. It's only auth app modifier. And what it does is make sure that the transaction originated inside Raffle. Which app ID? This one, Raffle app ID. And where is this Raffle app ID defined? Well, inside the constructor. So it's here, it's public. So once you deploy your contract, you define which Raffle app you want your smart contract to be linked with. And then afterwards, any transaction that is signed and submitted using this endpoint will pass this Raffle ensure authorized origin check, right? And now, if you consider what this brings, maybe just, okay, here's also the example how you use this endpoint with Python. So it's just a HTTP localhost and then / and then the endpoint address. This is the sign and submit example. So this is the complete Ethereum transaction. What this allows us is we can. So in the previous workshop, we had this chatbot, which is Telegram specific. So we have this centralized Telegram service. Now, what we can do with this powerful Sapphire feature that you can rest assured that all the conversation is kept secret, you can get rid of Telegram and just store all the conversation history on-chain. So you only have two components, your Raffle app, which is audited and provably like verified that it's safe. And you have the Sapphire smart contract storage, which is it's also provably working as it should. You can audit it at any time. All the upgrades are also audited, and you can check the history. And yeah, maybe just a proof of concept. I'm not sure why it doesn't want to go full screen. But basically, this is something what we did. It's a chatbot which runs completely on-chain. So when you want to send some prompt, you need to sign. Okay, so the question here was, can you explain the public-private cryptography? And then you sign the prompt with MetaMask. And then Raffle, on the other side, listens to events going on for that smart contract on Sapphire. And when something happens, now the transaction will be verified. Okay. And then when the transaction is verified, when the block is verified, it contacts the LLaMA service, locally inside Raffle, generates the response, and sends it back to the Sapphire smart contract. And then there's the user. Yeah, so this is the answer. And then the user polls the smart contract and gets the answer. Okay, so there is no like third-party service involved whatsoever. Everything is completely traceable and auditable, all the history. Maybe can you just pause and then at the end you can ask me. Yeah, and the architecture. I don't know. It went off full screen. I don't know why. So the architecture looks like this. So the user sends a prompt to the blockchain. And then the Oracle polls if there's any event. When the event comes, when there's a new prompt, it relays the question to the LLaMA service. LLaMA does the computation. This is done everything inside Raffle, inside a TE. The answer is returned and then stored back to the blockchain. Yeah. So this is the Oasis node. This is ROFL, runtime on-chain logic. It is this Sapphire EVM chain. And then multiple Raffles can connect to this on-chain TE component. Okay, maybe just a few words about the hackathon. So these are our tracks and our prizes. So deliberately, we have two tracks. The one we encourage you to attend is, well, build your Raffle app. So this can be just a pure Raffle app without any blockchain communication whatsoever, or you can do Sapphire integration as well to get some extra points. Okay, so the Sapphire integration means that you use this ensure, where is it? Yeah, that you use this Raffle ensure authorized origin subcall for authentication, for example, or to do some other stuff that you would have relied on some third-party services otherwise. Okay. So this is track number one, and for other dApps that are really purely, EVM-ish, that don't require any off-chain services, off-chain logic to be used whatsoever, we have a special second track, but the bounties here are much lower. And this track number two is basically a copy-paste from the last year's ETHDam, when we just try to encourage people to build on Sapphire, so a pure confidential EVM chain without any off-chain components. Okay, and then we also had have some other pools. One is for developer feedback. So if you join our communication, join our channels, Discord and Telegram, and help out others, pose important questions. Also, if you open issues at our repositories, either Docs or Oasis SDK or Sapphire, yeah, you will get award for this. And then there's the general pool, which is just distributed equally among all bounty hackers. Okay, when it comes to judging criteria, I just like to point out the innovation. So it's not just, we have a bunch of examples, and we encourage you to try to integrate some other technologies we didn't think of. So yeah, AI agents, LLMs, this is pretty obvious. Can we do something completely else? I don't know, like Raspberry Pis, sensors, video image processing, I don't know, whatever. So there are these technologies, number of, one is the real-time databases, I don't know. So up to you. This is probably the strongest part we're looking for, like combine fancy new ideas with the technology that we built. Okay, and yeah, the bonus point is if you use both Sapphire and Raffle together. Okay, the resources. So our documentation is at docs.oasis.io, and then you have this build section where it covers both Raffle and Sapphire topics. So just go through, maybe check some examples, and you'll get your hands dirty quickly, right? The OPL is Oasis Privacy Layer. These are the tools for making bridges between other chains. Usually, how it's used is that you have the original dApp running on some non-confidential chain, and then just want to have specific features to be exposed to be running on Sapphire. So yeah, these are the tools here. It's called OPL, Oasis Privacy Layer. And then the playground.oasis.io collects all projects that should be noted from previous hackathons. So it's a good collection to check them out. And then there's this cheat sheet, which Diana printed, and it's spread across this floor. You can also check it out here if you don't like the paper version. And I also have some prints here at my backpack, so feel free to poke me. Okay, and I think this is it. Cool.
Thank you very much. Are there any questions? I saw a hand go up there.
Yeah.
Hold on.
Yeah, in your example, is the answer of the LLM stored anywhere? Yeah.
This one here.
Yeah, and the slide after that, like.
Yeah, so the LLM is running inside LLaMA inside Raffle. So you need to download a few gigabytes of data and put them in this persistent storage.
But context gets saved.
Context, there is no. I mean, there are prompts. So for the history, you need to always put the whole history along. That's a standard. But the model is just the original DeepSeek 1.5. It's not trained on anything else. But you could. I mean, this is not the privacy issue. This is just technical engineering. You need to train on whichever app you want to build, right?
Yeah, cool. Thanks.
There's another question.
Any more? Oh, yeah.
Thanks for the talk. I wonder if we could run a publicly exposed web server inside a ROFL. Is it possible, or is it discouraged somehow?
Yes, it is possible. So inside the Oasis node config file, you can specifically say this Raffle app ID has these ports exposed externally. But the issue here is that the node operator then needs to give you, the public address and the port which you connect to. So it's not automated. You need to contact the node operator and say, hey, can you open that and that port and make it publicly available. But it's not. So the idea in the next few months, we're trying to. Okay, so when you want to deploy your Raffle, you find appropriate plan, because you actually, that's similar to what we have in cloud providers. You rent some machine and X amount of memory, storage, CPUs. And here, the fourth parameter would be the number of external ports you are going to rent as well. So once you decide which offer is good for you at which provider, then you submit this rent transaction on-chain. And you also pay for this rent, and the plan is for like a month or an hour or so. In our testnet, it's just 1 hour for your hackathoners. So the default testnet endpoint is 1 hour plan, and I think 2 CPUs and 4 gigs of RAM. Right, and at that point in time, when you register, when you rent an offer, you get the machine back, and that machine should also then contain, okay, I assigned you that and that and that port. Go ahead and use it for your app. So that's the design that we're having in mind to implement it in the next month or so. Yeah, but yeah, it's a great question, because we have a decentralized network, and now you want suddenly to bind some centralized DNS records to that swarm of nodes, each having its own IP address and exposed port. But yeah, so it is possible, but currently it's really rudimentary. So yeah, you can ping me and then I can open ports for you, but it's not automatic yet. Yeah.
Yeah, time for one more.
Is it somehow possible to run a scheduled task? So say, let's say once every hour or well, something like that.
The service must run all the time, but basically what you're asking is, yes, smart contracts don't allow you to have this cron job, right? And in our case, if you set up Raffle, yes, you can have exactly services, cron jobs running all the time.
But then would you have to pay it continuously, or you only pay?
Currently, yes. Currently, the plans are like fixed, like hour, month, and so on. You don't pay just by the amount of you spend time running, like CPU time executing your app. Yeah, we're still. I mean, it will be possible and it will be implemented someday, but it's currently just a fixed plan. So if you don't use it, well, tough luck. Yeah.
Amazing. Thank you very much.
Thank you.